Good afternoon. I'm Dave Munson, the Robert Vlasic Dean of Engineering, and on behalf of the College of Engineering, welcome to the wall-breaking ceremony. We've never had one of these, but we'll do anything for nuclear engineering. So we're looking forward to that in a few minutes. For those of you who traveled from out of town, a special welcome. I know we have some people who traveled a great distance to be here, who've had illustrious careers here in the past, so that's a pretty neat thing. If you're wondering what wall we're going to break, you have to wait, stick around, and we'll figure that out. I haven't actually seen it myself, but I have an idea of the direction we're heading. So we're delighted to welcome you to campus for this celebration, whether you're an alum, a friend, or supporter of nuclear engineering and radiological sciences. And we're especially appreciative for all of those of you who made this project possible. You'll be hearing from two of those important individuals later on. I'd also like to acknowledge the talented faculty and the students and staff, both past and present, whose hard work and amazing legacy we honor today. So thanks to them. You're going to be hearing from some of those folks as well, just a little bit later in the program. A special greetings to University of President Emeritus Jim Duderstadt. Jim's formal title is University Professor, but we all consider him to be Professor of Nuclear Engineering and Radiological Sciences. So thanks for being here, Jim. Among the numerous outstanding departments across the College of Engineering, all of which are home to world-renowned faculty, outstanding students, and impactful research and programs, there's only one that is officially number one in the main survey, and that department is NERS. For 2 consecutive years and 8 of the last 10, regardless of how many times and ways U.S. News changes its methodology, NERS is consistently the best program of its kind in the land. And today we celebrate this as an exceptional department that is positioning itself to become even better in the future. Under the excellent direction of your chair, this department is building on its historic greatness. Research dollars per faculty member are among the strongest in the college. New faculty are expanding the department's scope of inquiry. Undergraduate and graduate enrollment is still strong. All of these positive factors have resulted in increasing needs for space. Moreover, it is imperative to create lab environments that meet the needs of current and future major research programs. The NEL, the Nuclear Engineering Laboratory, will expand the department's world-class capabilities in areas such as nuclear nonproliferation, nuclear reactor safety, and homeland security. Through the construction of the NEL, NERS will move into a new era of breakthrough engineering leadership. Adjacent to the University of Michigan Energy Institute, which is where we're sitting right now, the NEL also strengthens North Campus's position as U of M's interdisciplinary focal point for energy research, work that will drive global environmental and economic solutions. In addition, the NEL will provide new, modern spaces for students and faculty collaboration and planning, including, I should say, one of the best views of North Campus, because for those in the top of the building, you'll be overlooking the class of 47E reflecting pool and the so-called Fred's Fountain. Now, I know a lot about this because I have a very similar view from the other side. So actually, I'll be watching you as you do your research. But seriously, thanks to everyone who has contributed time, expertise, financial resources, etc., to the establishment of the NEL. I share your eager anticipation in seeing this exciting project reach its completion, and I look forward to the next phase of uncommon engineering contributions here at Michigan for the common good. So congratulations to the entire NERS community. And now please welcome to the podium Chihiro Kikuchi, Collegiate Professor and Chair of the Nuclear Engineering and Radiological Sciences Department, Ron Gilgenbach.
Thank you, Dave. Let me add my welcome to the wall breaking for the Nuclear Engineering Laboratory building. I'm pleased to acknowledge and thank our distinguished guests, especially Mary Ann Beyster, Gladys Knoll, and Jim Duderstadt. and the NERS External Advisory Board. And all of you have helped make this building a reality. Most of all, I would like to acknowledge 3 of the icons of nuclear engineering who have sadly passed away before they could watch this building being constructed, especially Drs. J. Robert Beyster, Glenn Knoll, and John King. Dr. Beyster was a loyal UM alumnus who made pioneering contributions to accelerator-based neutron thermalization measurements that made nuclear reactor design possible. He was the founder of Science Applications Incorporated, a company that made tremendous contributions to nuclear science and national defense. I remember giving a short presentation to Dr. Beyster some 4 years ago about the NERS Department's nuclear nonproliferation program plans. First, he commented that we would need a particle accelerator to do active interrogation to detect special radioactive isotopes. When I explained that the NERS Department did not have any space for a particle accelerator, within about a nanosecond he said, "What about the old reactor building?" So that conversation led to Dr. Beyster's generous financial contribution, which kicked off this project. The NEL building will house a display commemorating Dr. Beyster's many contributions to nuclear science and engineering. Professor Glenn Knoll was a member of the NERS faculty for over 50 years. He founded the nuclear measurements program in our department and served as department chair and interim dean of the College of Engineering. Glenn trained countless students in the field of nuclear measurements. So it is entirely fitting that I am announcing that Gladys Knoll has funded a major laboratory on the 3rd floor, the Glenn F. Knoll Nuclear Measurements Laboratory. Professors He and Weehy will occupy the new nuclear measurements lab space, which also will display Professor Knoll's career highlights, commemorate his legacy, and no doubt inspire future generations of nuclear engineering students, faculty, and staff. Professor John King received 3 UM degrees and served on our faculty for some 3 decades, including a term as chair. He devoted much of his career to training students and conducting seminal research on neutron scattering using the Ford Nuclear Reactor, formerly on this site. We are undertaking a campaign to commemorate Professor King with a student collaboratory, which will be constructed on the 4th floor. This collaboratory will provide much needed space for our students to work together on their course and research projects. I'm pleased to report that MIT Professor Emeritus Sid Yip, who received his PhD from NERS, helped initiate this campaign, and he has kicked it off with a generous gift that brings us up to half of our goal for the John S. King Student Collaboratory. Sid? Finally, also on the 4th floor, a nuclear engineering laboratory conference room will be named after Harold N. Cohn. Mr. Cohn was a 1947 graduate of aeronautical and astronautical engineering, now known as aerospace engineering. Along with his brother and cousin, he engineered and developed numerous properties in the New York area, including Independence Plaza in Tribeca. It is appropriate that the conference room bearing his name will overlook the class of 47E reflecting pool. So thank you to the Cohn family. These laboratories and other collaborative spaces will continue the tradition of the Michigan Memorial Phoenix Project, a memorial to those members of the University of Michigan community who lost their lives during World War II. The research funded by the Phoenix Memorial Project literally changed the world. Some of the more notable examples include initial studies of cosmic rays conducted by Donald Glaser. Glaser's work led to the Nobel Prize for the bubble chamber. Pioneering studies on the treatment of thyroid cancer with radioactive iodine, conducted by William Byrewaltis. The first conversion of an existing nuclear reactor at a university from high enrichment to low enrichment uranium, and measurement of the gravitationally induced phase shift by neutron interferometry by Sam Warner. I would also like to recognize Walter Wegst and William Dunbar, 2 of the first operators of the Ford Nuclear Reactor who are able to attend today's event. Walter and William. Looking towards the future, a number of new laboratories will be housed in this building, including the Detection for Nuclear Nonproliferation Laboratory and the Consortium for Verification Technology, directed by Professor Sara Pozzi. This laboratory will make the world a safer place by developing new techniques and guiding policies to detect nuclear weapons materials. I will let Professor Pozzi describe these goals and objectives in more detail in a few minutes. Professor Annalisa Monero will direct a new nuclear thermal hydraulics laboratory that will improve experimental capabilities regarding the safety of nuclear reactors. These experiments will use X-rays to explore the dynamics of water and steam in nuclear systems. Dr. Monero's graduate student, John Downing, will describe some of the great research they expect to perform in this new laboratory. Professor Zhang He and David Weehee will continue to develop the world's most advanced gamma-ray cameras in the Glenn F. Knoll Nuclear Measurements Lab. These gamma-ray cameras have led to a spin-off company that is providing these systems to nuclear reactor facilities around the world to improve the safety of their personnel. Professor Michael Atzmon will develop a new laboratory on metastable materials, and a new faculty member who arrives in January will develop another laboratory that focuses on innovative techniques for detecting radioactive materials. In summary, this new building will lead the Nuclear Engineering and Radiological Sciences Department into a new era and explore the use of ionizing radiation for a range of applications from homeland security to nuclear nonproliferation, radiation detectors, and nuclear reactor safety. I'm not exaggerating when I say the Nuclear Engineering Laboratory is a dream come true. And again, we thank those generous donors and supporters who made it happen. Thank you. At this point, I'd like to introduce Professor Sara Pozzi, Director of the Consortium for Verification Technology, who will describe what this laboratory will mean for her exciting nuclear nonproliferation research. Sara?
Thank you, Ron. What a tremendous honor to be here today and to be speaking to such a distinguished audience. On September 11th, 2001, I was still living in Italy. I remember the news of the attacks and the feeling of vulnerability that came with the realization that there were people out there ready to commit such crime and such destruction. I immediately thought of the potential of a nuclear explosive or device being used against a civilian population. Shortly thereafter, I decided to dedicate my career to the study of nuclear nonproliferation. Nuclear nonproliferation aims at curbing the spread of nuclear weapons worldwide, and hence is tightly related to the prevention of nuclear terrorism. While at the Polytechnic in Milan, I studied Professor Glenn Knoll's book and was inspired to move to the United States to pursue my dream. Here at the University of Michigan, with the new nuclear engineering laboratories, we will address detection in ways that were not possible before. The state-of-the-art laboratories will enable the study of active interrogation, these techniques have shown the potential to detect shielded, highly enriched uranium, which is one of the major challenges that still remain. We will study imaging and source characterization to be able to detect uranium and plutonium inside a complex background. We want to thank our donors for their generosity that will make the nuclear engineering laboratories come true. Our students and faculty will continue the legacy that Dr. Beyster and Professor Knoll initiated. Dr. Beyster and his organization in the area of active interrogation and screening of cargo containers, and Professor Knoll and his students in the area of radiation detection and imaging. The research done here at UM in collaboration with 11 other universities and 9 national labs that are part of the Consortium for Verification Technology will deliver new instruments and methods for nuclear nonproliferation, safeguards, and arms control treaty verification. We will train the next generation of students in these areas. Ultimately, our efforts will contribute to making the world safer. If we can make even a small progress in this direction, I will have fulfilled my dream. Thank you very much for listening.
Thank you, Sarah. Now I'd like to introduce John Downing. John is a graduate student of Professor Annalisa Minera, and he will be telling us all the great things they're going to be able to do in their new nuclear thermal hydraulics laboratory. John?
Thank you, Professor. Good afternoon. I am thankful for this opportunity to address you guys today, and honored and humbled to represent the students current and future that will benefit from the donations and the foresight that's being highlighted today. As you've heard, the new building will contain offices, conference rooms, and laboratories. Excited for the prospect of an office with a better view. Heard the second floor isn't necessarily going to provide that, but I'm more excited for the research space that we're going to have. Space is a key part in being able to scale our test facilities appropriately, to be able to capture the phenomena that we're interested in, and to be able to use measurement techniques that will give us the high fidelity information that we want. So yeah, with that lab, we will have about 1,200 square feet, which is a sizable upgrade. We'll have more flexibility in the space as well for utilities that are available to us. Electrical power is a big plus. That will also allow us to scale things up to be operating our facilities at closer to plant levels. We're also able to have some flexibility through the floor to access the basement for larger facilities, more complicated systems that need time for development, both in like fluid flow or heat profile development. The walls that exist in the lab will also provide sufficient shielding for us to install or to begin using gamma ray and X-ray tomography to capture measurements that we haven't been able to use other instruments to do. This is a big jump and an exciting opportunity, especially because this is going to be the only location where students will have access to such measurement techniques. This is an amazing opportunity for us as students here. And the insights that we'll be able to gather from those measurements and the other research that we'll conduct will play a key part in shaping the future of nuclear power. And we're thankful for the opportunity to be a part of that, and look forward to developing sufficient databases and predictive capabilities to ensure more safety for plant operation and workers at those sites. I'm very thankful personally as well to be a part of nuclear engineering at this time here at the University of Michigan. The donors, the faculty, the administration have had our interest at heart and really have given us an opportunity to succeed. And for that, I say thank you.
I'm sure that everyone here knows Gladys Knoll, who with her late husband Glenn devoted themselves to the NERS department for over 50 years. I would like to invite Gladys to make some remarks about the legacy of the Glenn F. Knoll Nuclear Measurements Laboratory. Gladys?
Well, I just had a flashback when John was speaking, because it took me back to when we first came to Ann Arbor. It was in September of 1958. We had just driven across the country in our 53 Pontiac with a U-Haul trailer on the back after spending a year at Stanford, where Glenn received his master's degree. And we moved into University Terrace, which no longer exists, a little efficiency apartment. So when I talked to John last night at dinner, he was telling me that he was married and had 2 very young children. And we had 1 8/9 children by the time Glenn finished his doctorate. So I was also had another flashback when you mentioned John King, because John King was Glenn's co-chair for his dissertation. And his co-chair from physics was Parkinson, Professor Parkinson. And Glenn did his research work at the cyclotron main campus. And that thing kept breaking down. And he was afraid he wasn't going to be able to have sufficient data to finish his dissertation. And they would spend 1 week doing measurements, and then it would break down. Then they'd spend a week repairing it, and then they'd try again. And John King was the one who got him through that. So he's always been a real favorite of ours. So I'm so glad that he's going to be commemorated here also. Glenn had a great deal of respect for the work that Professor David Weehee and Professor Zong He were doing. And so when Ron told me, and I don't know if you did this on purpose or not, oh, who, me, that when I was looking for ways to commemorate Glenn's memory, he told me about this laboratory that David and Zong had designed as the laboratory of their dreams, and that did it. I think that's what persuaded me that this is where the money needed to go. Over the years, the university was very good to us. I have 2 degrees from the university as well. I was also a university employee. When we first came, I was a staff nurse, and then after my first child was born, I worked as a research assistant for another year. After I finished my master's, I spent a year as a lecturer, a year and a semester, I think, as a faculty member in the nursing department. So I'm also an educator. And having a lab like this, which will excite students to have a wonderful place to work, I think is a gift that I really wanted to make for you all. So I thank you for that opportunity.
Thank you.
It is now my pleasure to introduce a dear friend of the college, Mary Ann Beyster. Mary Ann is president of the Foundation for Enterprise Development. The FED supports U.S.-based science and technology companies by providing research, education, and services that promote innovation, entrepreneurship, and shared ownership. The foundation was established by her late father, our distinguished alumnus, Bob Beyster. Mary Ann has been actively involved with our Center for Entrepreneurship. In addition, she is an author, a publisher, and executive producer of the award-winning documentary film, We the Owners. Mary Ann, will you please come forward?
Thank you. It's an honor to be here. I'll first start with telling you a little bit about Dad. He would call himself a bricklayer. And what that really meant was he liked to identify problems, certainly if they were nationally important problems, and then look to build the solution piece by piece. That's the level of a detail that he would go into. And he really liked he liked the theory, but he also liked being applied. And a lot of that he learned here. One of the ways he applied this skill was in how he built a company. As it was mentioned, he founded Science Applications International Corporation. He was the CEO and chairman for 35 years. And he built it through a model that he called an atomic model. It was an atomic model of growth, profitability, and shared prosperity through employee ownership. And as you can imagine, there was a very small and very intense core, and he'd be in that core. And then there were all the other new businesses that came on board. So there were minority, majority-owned companies, subsidiaries, and joint ventures, all spinning around and growing this company. And you'd see the organizational chart that was this atomic model. The other thing he liked about science and the way he interacted with the scientists is he would really much focus on the small, but where it had a very big impact. And I think a lot, again, comes back to what he learned here. As a master's student here, he worked in Professor Weidenbach's lab, and that was in the physics department. And after that, there was absolutely no turning back. He got his PhD in physics. He wrote 60 technical papers in physics engineering, nuclear engineering and physics. He moved to Los Alamos. He then got a job at General Atomics to run the linear accelerator department, and then later started his company in 1969. And the first series of projects were all nuclear engineering and physics based, the first ones being with the Defense Nuclear Agency. And over those 35 years, if you picked any area of national significance for nuclear engineering and physics, he and the company were deeply involved, and he met with every single one of those customers and every single one of those scientists. So he absolutely cared about all the areas of nuclear weapons effects, nonproliferation, energy, medicine, and many other areas. So some of you know this, but I'll share with you. My father was born in Detroit. He was raised in Grosse Ile, but he was educated here at University of Michigan. All 4 degrees were from University of Michigan. So this is where he learned how to use his scientific discovery. So he's pleased, and he was pleased and honored to give this gift. And I have to say, last night was the first time I very much felt the presence of my father, who passed away 8 months ago. And that's because I was surrounded with people that are either nuclear physicists or engineers or lived with them. And they're a different breed, and they're a lovely breed. And and so it's really been amazing for me to come back here and be here with all of you. Thank you.
I could add that our computer science building is named for Bob Beyster, and when we commemorated that naming, many of his former employees traveled back for that occasion from all around the nation. And boy, was he ever adored by his former employees. Well, thank you to Gladys and to Mary Ann. We were greatly honored by the distinction that Glenn Knoll and Bob Beyster have conferred on this university, and deeply appreciative of the generosity of your families that you have now shown to the college and the department. And thank you to everyone for coming to witness this historic occasion and this exciting development for NERS. We ask that you now please follow us next door and downstairs for our ceremonial NEL wall breaking. In the meantime and afterwards, our reception is going to be continuing as it was before this event. And I would ask that the following individuals please come forward to join with Ron and me as we escort the rest of the group to the wall. Mary Ann, I'll be escorting you. And Ron, you're going to be escorting Gladys, correct? And we also want to make sure that our distinguished alumnus and NEL supporter, Sid Yip, is with us. So Sid, please follow us down.
One of the measurement techniques that we are actually designing right now, but then it will be built there, is what we call gamma tomography system. So what this is actually a measurement system that